Hi, everyone. Thanks for coming. I'm going to talk about a whole bunch of Puppet and Docker stuff. Hopefully it's going to be interesting. I am Gareth R. On the internet, pretty much everywhere. If you have questions afterwards, let me know. I'd be interested in what you thought was interesting and what you thought was dumb. As Brian mentioned, I work at Puppet, so you can blame me for a bunch of this stuff as well. I'm going to cover a whole bunch of things. So I'm going to talk a little bit about sort of a bunch of existing Docker support. We've had the Docker module around for more than 3 years. I want to include that, but I'm not going to talk loads about that. There are other talks and other bits and pieces that cover that. But I'm going to talk about a lot of things we've done over the last year. So I'm going to talk about the Puppet images up on Docker Hub and why and how you can use them. I'm going to talk about some of the running Puppet on top of some of the sort of containers as a service platforms. Talk a little bit about sort of the smaller OSs and how Puppet fits in there, and the stuff that was covered in the keynote around building Docker images using Puppet. I'll have that, and I'll talk a bit about inventory as well. Hopefully, I will get through all of that, and hopefully it will make sense and join up. And I'm going to try and throw in as many demos as I can get away with into the mix. The internet is broken, for those that haven't been following the internet, about how the internet is broken. So some of these demos might not work. I have lots of them, so some of them definitely will. It will all be fine. First, a quick summary about the existing sort of Docker support stuff that's been around for a little while. But actually, before I do that, so something else first. Who in the room, hands up if you're using Puppet? No one fell for that one. Keep your hands up. Keep your hands up if you're using Docker. Keep your hands up if you're using Docker in production. Lots of hands. Thank you. So it's interesting to know who is in the audience and which bits you'll find interesting. So with Puppet, a lot of content is distributed as modules. Lots of the modules cover specific bits of technology. There is a Docker module. It's up on the Forge. It's had something like 900,000 downloads now, from the Forge. It's been a really active project. This is something I started actually before I joined Puppet as an employee, but continue to maintain. It's coming in on 1,000 commits, so it's certainly changed a lot over that lifetime with the changes to Docker and just improvements in general. It's also really impressive that there's 137 contributors so far to that. It's under my namespace. People go, it's Gareth module. Actually, most of the work for a while, and certainly well over 50% of the work has been done by you, individually or collectively. It isn't quite as old as Docker, not too unsurprisingly. But I think it was the first version shipped maybe 2 weeks after the open source release of Docker. So it's been there from the start. It exists. People use it. A nice quote from a customer. It really fit pretty much every need that we had. I'm sure there's some users in the audience, and I won't dwell too much on it. But the core of that is you have a bunch of machines with operating systems, and you want to get Docker on there. Puppet is the easiest way of doing that by far. The simplest version is literally just include Docker, and you're done. But you can also configure all the different bells and whistles that Docker has. And this will just work like any other Puppet module. You can also, there are other types in there for actually launching containers. So maybe you're using a sort of fancier scheduler, and you're better off at that level. But sometimes you want, for example, a certain container to run on every host. And the schedules don't always have sort of things which make that easy. Well, just simply defining them in Puppet, where this is really an analog for a package in a service in the sort of more traditional world, that's pretty handy. With the addition of networking support into Docker, the module supports Docker networks, so you can get these into Puppet. There's a separate module for actually installing and managing universal control plane, which is part of Docker's commercial stack, and we're going to be doing a lot more with data centers in general. It's also, the module is often used by other modules that rely on Docker being there. So for example, the Rancher module like that is all the code you need to get up and running with like an entire Rancher stack. And a lot of that is actually powered by the fact that Rancher are using Docker as a distribution mechanism, and Puppet can already deal with Docker. So that's quite a good pattern. There's loads of stuff about like all of that and how to do that in production with all of the security bits and pieces that Scott Colton mentioned in the keynote. I'd really recommend reading this book rather than listening to me, because Scott has taken all of that and actually done a really good job of describing how you would do that in the real world. So definitely read that about how to like set up and manage Docker. I said I'm not going to do any demos of that. I just wanted to provide that context. What I do want to talk about mainly is like new stuff, or things from roughly the last year or so. And one of those is some work we did under the sort of Puppet in Docker banner, where we shipped a load of images up to Docker Hub containing Puppet software. This is all available open source. This is the actual repository for the build tool chain. So you can actually build these yourself if you want to do. You can see how we're doing it. You can see what's going in there. And we'll be adding more over time. Or if people want to submit other images, like having them all in one place is really nice. As mentioned, these are all up on Docker Hub. They're all under the Puppet namespace. There's a whole bunch of them. We're also one of the launch partners for Docker Store. So I think that's not quite out of private beta at the moment, but once that's available, there'll be all of that content on there as well. So what sort of things does this allow you to do? Well, there is a factor container, and you can Docker run Puppet factor. The reality is that's going to actually give you a bunch of facts about the insides of a container that then shuts down, which is of questionable value, but I'll show you why it's useful and valuable with some demos later. There's also a Puppet agent container image, rather. So you can run, and in this case, I'm passing apply as the command, and I'm just doing an inline thing. And you can diff that, and you can see that the container was changed. So actually, for that sort of experimental, what would this do? Would this compile? Would this run? Having like the sort of very fast feedback cycle of an ephemeral container works really nicely. And let's get on to some demos, because a lot of this makes more sense in like practice than theory. So, is the text big enough at the back? Someone's got their hand up. I'll take that as a yes. So let's just run some of those commands that were up before. So I say running, all that's doing is taking the image, which I already have locally. It's going to run factor and dump everything out. And we can pass the standard sort of factor commands. So, oh, look, it was in a Docker container. So there, I'm just saying, tell me the virtual fact, and the virtual fact is Docker. So we've got some detection bits and pieces in there. But let's try to do some things that are a bit more interesting. Let's find the previous ones. Here we go. So here I'm naming a container, but it's going to run an exit. And I've just passed some inline Puppet code. And I've run apply. But obviously, this could be agent. This could be anything. These could be any of the Puppet commands. And I could run. No, and I don't want to name it, do I? Like, Puppet is there at inside the image. So here it's sort of nearly another distribution mechanism for those that are using Docker. I named that container that shut down, which I did the apply on. So there I'm simply just doing Docker diff tells me what has changed about that container from the image. And I'm just saying, well, I'm grepping for the file that I added in the inline. And like, yep, that was there. That's sort of useful from a learning Puppet point of view, for an experimenting with Puppet point of view in a really disposable way. Doing that with a sort of a VM has a much longer cycle. To the extent that I think sort of workflows like this don't really exist in the Puppet community today because the feedback cycle is too long. actually building on top of Docker gives us the ability to have that feedback down. I think there's some workflows that can fall out of that. So far, not that interesting, but we're getting somewhere more interesting, hopefully now, because we've not just packaged up sort of Factor and Puppet Agent, and I'll come on to some better demos with those later, but we've also packaged up PuppetDB, Puppet Server, and actually some of the open source community dashboards as well. So you can actually run your Puppet infrastructure on top of a container as a service platform as a set of containers. So if you want to just get up and running and like quickly boot an instance of Puppet Server, well, you can just run something like this. I mean, here I'm giving it a specific host name, and I'm giving it a name, so I can get it back later, and I'm assigning it to a network. But actually, the important bits there are Docker run Puppet Server. At the moment, we've pushed out a lot of images for all the open source components, but we're definitely interested in doing this for how Puppet Enterprise is sort of composed as well. So if you're interested in that, definitely talk to your friendly salesperson and get in touch. So we've broken it down into a bunch of images, Puppet Server, PuppetDB, different dashboards, different bits. Actually, we can then put it back together as a stack and launch it with something like Docker Compose. So there's a compose file in the examples, and let's go have a look at what that looks like. So let's go here. So I'm in a directory with a bunch of bits and pieces. I think I want to. Oh, sorry, I need to clean something up first. Thank you for Z for adding that. So all I've got in here is of interest really is a Docker Compose file. So Compose is a YAML file format where we can describe a series of containers that are going to be like related, and they're going to be linked together, and they're all going to boot from one command. And we can see here we've got a database, Postgres database to back PuppetDB. We've got Puppet Board. We've got Puppet Explorer. We've got Puppet Server at the top. But let's get that launched. Oh, it's Docker -compose, isn't it? That'll take a minute, because ultimately there we're taking sort of 5 containers and we're booting all of them. And so this'll take a few minutes, but this is on my local machine. This is on a tiny MacBook, and we're booting the entire like sort of open source Puppet stack locally in like a couple of minutes. That's a much faster feedback cycle than is certainly possible with sort of if you were doing this in multiple VMs. In most cases, well, if I tried to boot multiple VMs on this laptop with running this software, that's not going to work. I've got a few, there's not like, well, and this is 8 gig of RAM, and it's running an operating system in Chrome, and Chrome will eat most of that. But this is giving us a way to actually, I think most people's local usage of Puppet is often centered around sort of apply-based feedback models or sort of simple VM-based sort of apply-based models. And in production, you're often running like PuppetDB and Puppet Server and the rest of it. This exposes Puppet, that sort of like those bits and pieces, much, much more easily to a local developer. And not in the context of a local developer working on these products, but in like someone who's just a Puppet user. So one of the things that I've been really interested and excited about as I've been using this is the ability to do a lot more with PuppetDB. Having a really simple way of getting PuppetDB up and running locally. Like the PuppetDB API is fantastic. PQL, the new Puppet query language, is really, really powerful. And being able to sort of experiment with that and play with that locally means that you can build amazing things in production much more easily because you've not got that sort of barrier to entry to get there. So hopefully that's launched a whole bunch of containers. Let's make that a bit clearer. And you can see there's a PuppetDB one, Puppet Explorer, a bunch of other bits and pieces. Hopefully, it's not quite all up and running, but in that compose file, we basically exposed one of these dashboards, Puppet Explorer in this case, to the local host. I'm just grabbing the port there. So for that, I will need a web browser. So I'm just grabbing the port there from Docker port, and Puppet Explorer's come up. There's some data in there because I had the database was already, the database container was actually booted before. So this is one of the interesting areas where we can use some of those agent bits and pieces. So all I'm doing there is launching I'm using Docker Run to run a Puppet Agent Alpine-based container, and that's an agent. That is good. I'm connecting it to the composed network that all the other bits and pieces are on. And that's going to launch. It's going to talk to the Puppet master, and so you can see the certificate signing going on here. I've just got auto sign on, but you could change that. That master has actually a little bit of Puppet code in the sort of environment that's adding a file at temp Puppet in Docker. Nothing exciting, but we've got a whole Puppet agent workflow going there in a couple of minutes with the entire stack, and we've got all the dashboards for people to play around with. And again, I think this exposes a whole bunch of sort of API surface and a bunch of developer workflow stuff that we can make these tools, you can incorporate them into your local development much, much more easily. And a whole bunch of testing scenarios here as well that, again, that's an entire agent going from nothing to something, to then disappearing, but allowing us to look at it afterwards. A whole bunch of sort of workflow stuff there, and I'm finding that really handy and useful. That's all available today. There is a repository of examples. So, well, running that locally is one thing that's sort of interesting. Actually, running it in something like a SaaS type sort of container as a service platform is really interesting, because then you can actually get up and running with a full Puppet stack, PuppetDB, Puppet server, in a very hands-off infrastructure way. Actually, exactly the same as I just did locally. I won't try this with the internet, but the examples are in the repository. And the one I've been playing with most is Hyper. It basically exposes the Docker interface, but actually is on the internet. It's really nice, really handy for demos in particular, when there's the internet isn't broken. And Container Engine as well, in a similar way, as one of these sort of hosted services for running things on top of. And you could do this as Amazon ECS as well. It's totally possible to get up and running with a full Puppet infrastructure based on these images very, very quickly. For the moment, I know some people are trying this sort of approach in production. But I think we're going to do a lot more work around what are the best practices there, because we can be quite interestingly specific, especially with something like Kubernetes, which powers Google Container Engine. Which bits can be replicated easily in a stateless manner to scale out as your infrastructure gets bigger. And I think over time, we can use some of this underlying technology to make the maintenance of a Puppet stack, whether it's Puppet Enterprise or the open source version, a lot easier to manage, and also actually a lot easier to upgrade, because some of the platforms like Hyper or Google Container Engine contain primitives for doing sort of rolling updates and all the rest of it that we can just take advantage of because we're on top of them. I mentioned the Puppet in Docker repository, which has all the build files. There's also a Puppet in Docker examples repository, and these are all under the Puppet Labs GitHub namespace. So there's a whole bunch of other examples in there. There's things like running Puppet server on Windows is suddenly possible if you're using Docker for Windows, for example. That's often been an issue when I've been on Windows and actually I need a VM to launch Puppet Linux to run Puppet server. Now I can just do Docker run Puppet server standalone, and it's all up and good. So that's sort of one area. I'll have a quick glass of water. Something I'm super interested in is the sort of I guess, collapsing of operating systems. We're still predominantly using very high, sort of big general purpose operating systems that are useful for everything. But actually, some of our workloads, especially when it comes to sort of large scale sort of web application type stuff or the services that back those, don't really need most things in a general purpose operating system. And we're seeing this sort of movement and experimentation around things like Photon from VMware, Koros, Atomic, Nano Server that Jeffrey Snover mentioned in the keynote today. I think this is really interesting. One of the parts there is that these operating systems are simpler. The surface area for things to manage is reduced. It's not it doesn't disappear. There are still things there, but it's massively smaller. And the idea that we can use Puppet there to manage a much smaller surface area for things to manage versus having to manage everything or make trade-offs about how many files you manage on disk I think will simplify the usage of Puppet, but amplify its usefulness, because you're probably going to have a lot of these. And this is where we come back to the factor and the Puppet agent containers and why they're useful. So in all of these cases for those operating systems, the unit of software is a container. It's basically that you're either the operating system, and that's coming from the operating system vendor, or you're a container. We're not an operating system vendor, therefore the only way to get software onto those machines is with containers. But you can do gnarly things. So this example is basically volume mounting directories that we want to actually be able to modify from the context of Puppet, or in this case, just know about from the context of Factor. We're removing it afterwards, and this is equivalent to running Factor on that machine. It's not going to tell us information about the facts in the container context. It's going to tell us about them on the host, that host being Koros or Atomic or Photon. So for example, obviously, I'll show a proper example of this in a moment, but flags is basically a environment variable for all of that mapping, and we'd like to do some user interface work really to make that nicer, so you don't have to know all the crazy bits and pieces of the file system you need to mount, but we can detect Photon OS. Factor has support for detecting these operating systems. And Puppet has support for the package managers that have been used in some of them as well. So TDNF in Photon OS is basically a tiny version of DNF, the package manager in Fedora and coming to the RHEL family. Well, Puppet has support for that. It has a provider for that. We can detect the packages and the versions of the packages that are installed on Photon, and you can manage them. You can install them, upgrade them, do everything you're used to doing for a new style operating system where everything is a container. There's a blog post about this from just last month, I think, or maybe a bit longer, which contains all the details, but I'll show a quick example. I will shut this down before my computer complains. Oh, I forgot what it is. Compose down, is it? I've forgotten. Yeah, there we go. So in this case, I am going to launch VM. So I've got a local hypervisor. I'm using Vagrant to boot a VMware Photon OS machine. That'll take a moment to launch, hopefully. But what I'm going to do then is play with Puppet on that machine. Again, there isn't a TDNF, a TDNF sort of package. You don't control the repositories. It's everything is about launching things as containers. And to make that a little bit easier, given it's a Vagrant machine, I've just got a make file that's using Vagrant to run commands in the context. So we can see that once that's booted, we'll be able to run Factor. We'll be able to run a Puppet agent if we wanted to. Sync is just going to copy some Puppet code to the machine. Let's go have a look at that Puppet code. Here we have oh, screen's gone. Oh, hello. Is it coming back? Hey, thank you. Yeah, very simple Puppet code. We've just got a heradoc of a systemd config file, and we've got a package, a file, and a service. It's just Puppet code, nothing exciting to see here. And we're just installing etcd from the packages that are available on Photon. So, yeah, hopefully that's up and running. Let's find out. So I'm using make just as a user interface, and partly because those commands are long. And all I'm doing, the command that was running was literally just factor OS. And we can see that Factor successfully detected that this was a Photon OS machine. But let's do something a little bit more interesting. I think it was apply. So this is starting off, it's copying that Puppet code to the machine. I'm just using apply here, but we could do this with an agent. If I set up a whole master, I could have kept my master running. Oh, I could not find file. That's probably let's try that. Moment of truth. I think that's working. So yeah, here we're running Puppet from inside a container. We're mounting parts of the underlying host, including like var run dbus, for example, so we can get we can manage services on the overlying host. And you can see here that at least Puppet, as far as it's concerned, it installed a package. It used the package manager tdnf. It put a file on disk for the system to unit file. It then used service to schedule a refresh of that and started up the service. And let's even check that it's running. So I'm just SSHing into the machine, which you shouldn't SSH into machines as we were told in the keynote, but this is a demo, so I'm ignoring that advice. etcctl is basically the command line for etcd. Well, that wouldn't have been there if it wasn't installed, but so we know it was installed. Is it running? There's a health check thing. I think it's health check. Let's go have a look. Cluster health. There we go. Just thinking about it. The cluster is healthy. There's definitely a member. It's this machine here. We were able to use the Puppet agent container to manage a host where all software is containers. This exact thing works with CoreOS, it works with Atomic, it's the same approach. At the moment, the user interface is rough, if you like, with that sort of volume mounting. We'll definitely do some work to improve that user interface. But if anyone tells you, oh, well, like with these new operating systems, you don't need to manage anything, they'll be like, I'm sure there's something to manage. There are fewer things. That makes, like, puppetizing a machine where there are fewer things to manage sounds brilliant to me. Like, the value in Puppet is not in how many resources you're managing on a host. That would be weird. At least I hope it's not. So, hold. Let's get rid of that. So, let's jump around a bit more. So we've covered a whole bunch of things to do with some images we've shipped to Hub. But you want to make your own images as well. You don't just want to run Puppet. We've sort of talked about how Docker makes maybe Puppet easier to run, potentially easier to manage, and certainly like opens up a bunch of opportunities for developer workflows. But you probably care more about your applications than mine. That's fair enough. Building Docker images with Puppet should be as simple as building them with Docker build. That was sort of the starting premise for some of this work. You already know and use the Puppet DSL, you know the language. You already have some of your services described. Why do you then have to re-describe them in a new format? Why do you have to sort of step down to Dockerfile? Potentially managing things in both means you're now maintaining two things. You need to keep them in sync. Sharing things becomes, and Puppet, the sharing story is pretty good. You can encapsulate things in modules. You can have those internally. You can share them externally. We have dependency management tools. Dockerfile is a line-oriented user interface to like running bash commands in the context of a build. It's beautifully simple. I think one of the things here is it's not about one or the other. I think you'll probably end up using both, and I'll show you how we've sort of dealt with that conundrum. One of the things about Docker is the user interface is approachable and easy and obvious, and then powerful and extendable when you need it to be. So like building is brilliant. You have a Docker file. You put some stuff in a Docker file and you run Docker build. Here we're saying, well, here's a name and the dot is a context, so it's like in this directory, and that's it. So basically you just type Docker build from a Docker file, you've got an image. With the new Puppet image build work, well, you don't even have to have, here we've got a manifest folder with an init.pp. That could be it. Like that could just be any name.pp, and you could override the defaults. I've got a Puppet file here with dependencies for modules, but you don't have to have dependencies. But the power of Puppet is often in pre-existing content. So as a hello world, this is pretty good. And here, we're just doing Puppet Docker build, image name, Gareth R. -t, I think, has a long form version. There's an extra word, basically, there, which is Puppet. So as a user interface, we're aiming for the same level of simplicity. The difference here is you can now use the Puppet language and all the power that comes from that to build your images. This is open source as of yesterday. I didn't update the screenshot. The screenshot is private. That's a lie. This is available on the internet today for people to play around with. Please do, and let us know. It's also up on the Forge, so you can download it from there. There's loads of examples and documentation. And let's go have a look at one of those examples now. This does require the internet, so fingers crossed, touch wood, etc. So there's a bunch of examples, one of which is simply very much a hello world example using Nginx to serve some content. So my application in this context is actually, I want my application to say like some words to us. So I've got a Puppet file, I've got a manifest directory, I've got this metadata file, which we'll come back to in a moment. But let's just have a look at the Puppet code. To serve my bit of text, in this case, hello Puppet and Docker, I'm going to drop a file on disk, I'm going to install Nginx, I'm going to set up a vhost. The bit at the bottom is sort of just a real world kludge. The Nginx module that I'm using doesn't support a parameter for saying don't demonize. And I want Nginx to run in the context of the container, so I don't want it to demonize. I don't want it to disappear from PID1. So this is just Puppet code. And I've written it for this example, and it's in a manifest here. But there's no reason this is an existing Puppet code that exists in your organization today. And I'm going to do a local example using a local file, but this also works with a Puppet master. So actually, you can just point it at a Puppet master, deal with the classification, and images will build. In the same way as Puppet has Puppet apply and Puppet agent, this works in both of those worlds too. The only novel bit is this provider, this dummy provider. There is no init system running in the context of a Docker build. So service resources can get in the way when they're for it. Like, if you were just writing vanilla Puppet code with no modules, then you wouldn't use service resources. They wouldn't make any sense. However, you have existing code, you have existing modules. They should work for this. And how we deal with this is basically this dummy service provider. At the moment, you have to be explicit. You have to actually add this to your Puppet code. Obviously, you could do this behind a flag for the virtual fact. Is this in the context of Docker? Again, we've seen the Docker exposes that virtual fact, so you can tie these things together. I think over time, we might make this actually implicit as part of the build tool. We'll see. The sort of an explicit versus implicit discussion there to be had. Let's also look at this metadata file. So it's worth saying that I could pass all of these on the command line. So I could pass -- command Nginx. So you don't need this. But as with Puppet, it's often useful to have files because we can version them. We can have control processors around them. We can store them alongside the code. So you can override them at the command line, which is nice for demos. But I do prefer the fact you can put things into files. This is just key value pairs. This is just metadata. So one of the differences between what we're doing and how Dockerfile works is Dockerfile mixes metadata with data. Some commands like run are to do with bits on disk. Some commands like label or from are metadata required to build the image. We've got a very clear split between those two things. Puppet manages bits on disk. The metadata file as key value pairs manages the metadata. So they're all it's just Puppet code. There's a Puppet file. Look at that for posterity. It's just a Puppet file. It's an existing one. Again, if you're using R10K or library in Puppet, this is reusing all of the bits of the Puppet ecosystem. So with all of those things existing, let's type correctly. We'll just run Puppet Docker build. Whoa, bang, that was done. That was fast. The reason that was fast is because I built it previously and it was cached. And for people that are familiar with Docker, you'll be going like, this looks like the output from a Docker build. It is the output from a Docker build. We're not trying to replace this. We're trying to augment the Docker build process. So as Docker gets better, this gets better. It also actually, the tool supports alternative build processes as well. So there's a tool called Rocker, which has a number of added sort of fancy features that I think really are outstanding feature requests for Docker build. I'm regularly using that. I prefer that as my builder. Well, the module supports just simply flipping from that to that builder with a command line flag. As I think there's some work going on with sort of factoring Docker build much more into the client side than the server side and where it's been. When that happens, I think we'll see an explosion of different build tools. We'll be able to be a layer on top of those to provide a way of using Puppet with any of the new build tools that provide whatever advantages they provide. Well, the cache thing is a bit boring, so let's try something a bit more adventurous. We don't want to say hello Puppet in Docker. We want to say hello PuppetConf. So I'll save my file. And let's run a build again. So again, we've got a workflow where I changed some code. I changed some Puppet code. And, well, now it's stopped. It's building. This will take, well, maybe a bit longer than it should do because we're on a conference Wi-Fi connection and the internet is broken. But this is going to work as fast as it can to, what it's obviously doing here is doing an apt-get update, because you don't want all of the package cache on there, so you need to do it for each step. But it's structured in such a way that the caching kicks in, so it's only doing what it needs to do to update the image. And we can see here actually, well, it's done that. It's loading some facts. It's doing a bunch of Puppet stuff. I think I'm using an odd module, so there's a bunch of deprecated things in there. Oh, it's David and his deprecations for the validate functions. Thanks, David Smith. But this will work. So before we just saw output from Docker because it was cached. Now we're seeing a sort of mix of output from a Docker build and from Puppet. So if you're familiar with both, it's quite nice. This is installing some things from the internet, which is taking a bit of time. That will work. We'll come back and use that in a moment. But hopefully that's of interest. So I mentioned that this is not really an attempt to replace existing tools. It's about augmenting them and different use cases, having sort of different user interfaces, especially if you have a lot of existing Puppet code. So you can actually integrate this into a Dockerfile-centric workflow. If you're already thinking, well, oh, this is cool, I'd like to use Puppet code, but I have a workflow based around Dockerfile, well, this tool supports it. So as well as being able to type Puppet Docker build, you can actually get the intermediary Dockerfile. The nice thing there is actually from a debugging point of view, you can see exactly what's going on. You could also use, and most of the code in this tool is actually about generating this file based on the metadata, based on the Puppet code, based on a number of inputs. And you could obviously version this file. You could do all sorts of things as a workflow point of view. I think it would be interesting for us to do more workflow-oriented, sort of add-ons and bits and pieces with this tool later. At the moment, the thing we've shipped is just a point solution to building bits. Sorry, Americans, this was a talking about. So far, that is a very Puppet-centric view of the world. You're writing Puppet, you're sort of you're to a degree at a distance, or you can choose to be at a distance from sort of Docker there. And I think that's a good workflow for some people. But there's a reverse bit as well. There's people who are sort of well, actually, we're into all the Docker tooling, but we want to use Puppet, rather than we're into all the Puppet tooling, we want to use Docker. I gave a talk about this specific topic at Container Camp in the UK, and so check out the slides. But there's some more, maybe more experimental work around this. The idea of sort of pre-processing Docker files. Because Dockerfile has a small syntax, and it's very sort of high level. It's sort of run, label, etc. Realistically, most of the work goes into run commands. But sharing those becomes a matter of copy and paste. And wouldn't it be nice if we could have more domain-specific extensions to Dockerfile syntax? So Puppet install, Puppet copy, Puppet file, Puppet copy manifest. It's like, well, that's not going to work in like if you just pass that to Docker build. They're not supported in the Dockerfile syntax. Well, that's where the preprocessor comes in. So what we do is we encapsulate in the preprocessor what is required to do these things. So you can just write this code, pipe it through the preprocessor, and you have a Docker file that will work. So if the first examples with Puppet Docker build are a Puppet sort of like angle of doing this, this is a Docker and Docker file angle of doing the same thing. But it's able to use the same patterns and practices and tools. And again, you can use Puppet code to tie all that together. That's quite good for advanced users, I think. It's also, if the opinions of Puppet Docker build are too strong, or you have specific, very sort of more unique use cases, then you can drop down a level. So, as I'm going, I'm sort of getting more towards like experimental bits. And this is the really experimental bit, but that's good fun. I've just got enough time for a demo, I think. So there's a module up on the Forge called Puppet Inventory. I'd love some more people to play around with this and see what they think. What it allows you to do is inventory any host. There's not much code there, but you can sort of see, oh, there's a resource, that has a title, it's a group. Imagine that for packages and users and all of the other sort of Puppet resources. It's very low level, it's just data. I'm piping it through JQ to get color on a slide that I colored in. But think of this in terms of, for those that are familiar with Puppet resource, this is sort of like Puppet resource for everything that gives you data that then you can Spelunk with. One of the interesting use cases for this is actually getting an inventory of an image that was not built with Puppet. This tool is actually, the inventory tool is actually integrated with the Puppet Docker build work. You get this for free if you build your images with Puppet. But if you don't, we still want this to be available. So there are ways like this of sort of basically volume mounting in Puppet inventory. And here I'm running it against a CentOS image. That doesn't have Puppet on. It doesn't end up with Puppet on afterwards. But you get an inventory of all of the packages and all the services and all the versions of everything that is on there. That sort of operational intelligence, sort of like what's inside your containers, should be a question that you should be able to answer very quickly. And in most cases, it's like, oh, it's a black box. That's the beauty of it. It's like, yeah, but like, what version of OpenSSL is running in there? And it's like, oh, it's black box. It's not a good answer. You can do crazy things with JQ and to parse this out. And again, like we're getting into the experimental hacky bits, but you can imagine higher level user interface and search boxes and GUIs here. At the moment, I'm going to demo things on a command line and pipe things into JQ because I'm like that. So let's try and do that. Hopefully. Here we go. So I'm going to cheat here because I'm a bit short of time. But the module contains an example inventory. And I say all this is, and we can generate this for any host. We can generate this for containers even if they weren't built with Puppet. You get this for free for your images. And it's just a data structure. The data structure is still in flux, but it'll be familiar to anyone from Puppet. I mean, like the concept of a resource. The most interesting things are things like packages. And in this case, it was an Alpine machine, and we can see the provider was APK, and the version of Alpine keys was 1.1. But let's rush and try to do something interesting. Too many examples. Here we go. So I built an image a moment ago using Puppet Docker build. I'm going to run a version of that image, and I'm going to override the command. It's not going to run the Nginx web server. I'm just going to grab the inventory from it. And that's just giving me loads of data about the contents of that container at runtime. So I can pipe that through JQ. I'm doing a crazy query there. JQ is basically set and awk for JSON. And I've got a lot of crazy query bits and pieces there. But imagine a higher level interface to this. Imagine it integrated into the Puppet Enterprise console, for example. I was able to ask a container, what version of OpenSSL are you running in there? And it said, hey, well, it was installed by apt. I'm running 102G. Like, what else would you like to know about me? So we can ask all sorts of things. I mean, like, I'm just asking questions about packages here. But we could ask questions about users. There's a weird thing in there of, like, if you're using sort of base operating system base images from Hub, they probably have a load of users. Why? That sounds like a bug. But most people don't look under the covers, and they don't have tools to look under the covers. This is what we're sort of starting to provide with the Puppet inventory work, like looking under the covers of containers. There's a few other demos using this out there that sort of one's a package search engine. So imagine integrating this with the Docker event API. So every time a new container is launched, you grab the inventory for that container. Remember, that does not involve Puppet on the machine, on the container. It doesn't involve having to add Puppet. We can generate those things separately. Every time a container launches, you can grab the inventory. We can index that and give you tools to search it. There's a simple package search example of that sort of thing. I've also been playing with streaming this information into Google BigQuery and having like sort of basically a data warehouse of inventory of every single container, every single machine that has ever existed. That's super interesting to play with. And the conclusion to all of this is that there's more to come as well. I think hopefully not everyone's familiar with all of the bits and pieces I've run through. I've run through them reasonably quickly, but I'd encourage you to have a play around with them. We're doing quite a lot, and we're going to do a lot more. And Puppet can help you manage containers, especially once you get into the gnarly world of production. And we're going to do a lot more in the future. But I also like the feedback loop bit here, because I think containers can help you manage Puppet. It can help us make Puppet more maintainable and easier to scale. And the fact that we'll be doing that will give us insight into like the problems of managing containers, and we have a really good feedback cycle. There's still loads of interesting problems. I get to say interesting because I work on building tools. If you're an operator, interesting is probably not the right word. But there are still lots of problems and solutions to find for those problems, which is the fun stuff, like around using containers in production in like sort of like messy, heterogeneous real-world environments. All of these demos are available on the internet once you can reach it. Do play around with them, ask us questions, and follow Project Blueshift on the Puppet website. A lot of this stuff sort of rolls up to there with lots of links to blog posts or releases or anything like that. And thank you very much for listening. I'm not sure I've got time for questions. No. But I will be around afterwards if anyone wants to come say hi. Thank you very much.